Today's lesson is lesson 12-4, multiplying and dividing rational expressions. We're going to look at 3 examples multiplying rational expressions and 3 examples dividing rational expressions. All right, go ahead and get down number 1. Number 1 is n squared minus 9 over n plus 3 times n minus 1 over n squared minus 1. Just like yesterday, the first thing we have to think about is factoring. So we're going to look at each individual section of each fraction and see what can be factored here. The first part we're going to look at is n squared minus 9. N squared is the perfect square of n times n, and negative 9, or 9, is the perfect square of 3 times 3. So we can go ahead and factor this by perfect squares because there is a minus sign in between. We know that that's the same thing as saying n 3 and putting a plus sign here and a minus sign there. So that's our first numerator. I'm going to write that down here. N plus 3, n minus 3. So let's look at our n plus 3. That cannot be factored any further, so we're just going to say n plus 3. And then on this side we have n minus 1. N minus 1 cannot be factored any further, so that's just going to remain n minus 1. But down here we have n squared minus 1. N squared is the perfect square of n times n, and 1 is the perfect square of 1 times 1. So that's the same thing as saying n plus 1, n minus 1. And we can go ahead and factor that and put it in the denominator. So now we are able to go ahead and cross out the things that cancel. So here we have n plus 3 and n plus 3. So we can go ahead and cancel those out. And then we have n minus 1 and n minus 1. So that goes ahead and cancels out. And now we're just going to make one fraction with what we've got left. So we have on top n minus 3 and on the bottom n plus 1. Guys, I'm sorry, I did forget to do my excluded values before I crossed out in my denominator, so we do have to go back and do that now. So I have to find my excluded values because my denominator cannot equal 0. So for n plus 3, when I subtract 3, n cannot equal negative 3. For my n plus 1 to not equal 0, n cannot equal negative 1. And for my n minus 1 to not equal 0, n cannot equal positive 1. So my excluded values are negative 3, negative 1, and 1. So make sure that you have your excluded values as well as your final fraction in its simplest form, which is going to be n minus 3 over n plus 1. That is my final answer. Make sure you have that down before you move on. All right, go ahead and get down number 2. It's b squared plus 5b minus 36 over b squared minus 8b plus 15 times b minus 5 over b plus 9. The first thing, again, we're going to do here is go ahead and factor. So I'm going to look at my first numerator. I have b squared, 5b, and 36. There is no GCF to be factored out there. So I'm going to go ahead and multiply my first times my last, which is going to be 1 times negative 36, which is going to give me negative 36. So I'm going to look at my factor sheet, and I'm going to list my factors for I'm going to list my factors for negative 36. I know that these factors are going to have to lead up to a negative. They're going to have to give me a negative 36. So one of my numbers is going to be negative, but then in the end they have to add up to a positive 5. So it's going to be my lower factor that's going to be negative in each of these cases. So 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Which ones of these are going to add up to give me a positive 5? It's going to be negative 4 and positive 9. So I'm going to break this up. I'm going to put it over here, b squared plus 5b minus 36. I'm going to break this up into negative 4b plus 9b, bring down my negative 36, and bring down my b squared. I'm going to factor my first group, my second group. First, I'm going to factor out a b. It's going to give me b minus 4. And then my GCF between 9 and 36 is going to be 9. That's going to give me b minus 4. So in my first set of parentheses, I'm going to have b minus 4. And in my second set, I'm going to have b plus 9 because I factored out a positive 9 there. So I'm going to go ahead and bring that over and put that in. My first numerator is b minus 4, b plus 9. Now let's look at our denominator here. We have b squared minus 8b plus 15. There is no GCF to be factored out, so the first thing I'm going to do is go ahead and multiply my first term times my last term, and it's going to be 1 times 15, which is going to give me 15. I'm going to list my factors of 15. Keep in mind, these factors are giving me a positive 15, but they're going to add up to a negative number, so that means that each of my numbers here that I'm multiplying would be negative. So my factors of 15 are 1 and 15, and 3 and 5. Negative 3 plus negative 5 is going to give me negative 8. So we're going to break this down. I have b squared minus 3b minus 5b plus 15. And then I'm going to look at my first group and then my second group. I'm going to factor out a b here. It's going to give me b minus 3. And here I'm going to factor out a negative 5, which is going to give me b minus 3. So in my first set of parentheses, I have b minus 3, and my second set of parentheses, b minus 5. Again, this is all factoring that we've been doing all along. So I'm going to put this on the bottom. B minus 3, B minus 5. And then here, B minus 5 cannot be factored any further. And B plus 9 is also fully simplified and cannot be factored any further. So now, I'm going to go ahead and look at my excluded values. I'm not going to forget to do that this time. And we're going to say that b minus 3 cannot equal 0 because nothing in my denominator can equal 0, and these are all in my denominator, so I have to look at each of these to make sure that none of them equal 0. So that means that b cannot equal 3. Next, b minus 5 cannot equal 0. So I have to add 5 to both sides, which means that b cannot equal 5. Here, b plus 9 cannot equal 0. So I have to subtract 9 from both sides, and b cannot equal negative 9. So my excluded values are 3, 5, and 9. Now I need to look up here and see what cancels out. In the last problem, I canceled from the numerator and denominator of the same fraction, but another way that we can cancel is actually across the multiplication sign. So we can go from here to here. This b minus 5 and b minus 5 will cancel diagonally. So you can cancel top and bottom, or you can cancel diagonally. Here, my b plus 9 cancels with this b plus 9, and I'm left with b minus 4 over b minus 3, and that is going to be my fully simplified answer, b minus 4 over b minus 3. So make sure that you have all of that down, work and everything, before you move on. All right, go ahead and write down number 3. We have x squared minus 10x plus 24 over x squared minus 16 times 2x minus 8 over 6x minus 36. We have all sorts of factoring things going on here, so we're just going to go ahead and take it one step at a time. We're going to look at the numerator of the first fraction first. So we have x squared minus 10x plus 24. There is no GCF to be factored out between x squared, 10x, and 24. All right, so I'm going to multiply my first term times my last term, which is 1 times 24. And then I'm going to come over here and I'm going to go ahead and list the factors of 24. The factors of 24, according to my factor sheet, are 1 and 24, 2 and 12, 3 and 8, and 4 times 6. The catch here is that I have to realize this is multiplying to give me a positive 24. However, when I'm adding these factors, they're adding up to be a negative 10, which means that all of my factors must be negative in order to get the right answer. So I'm going to find that negative 4 plus negative 6 are going to give me negative 10. So negative 4x minus 6x, and bring down my 24 and bring down my x squared. And then I'm going to factor each of these groups. So my first group, I'm going to factor out an x, which is going to leave me with x minus 4. And in my second group, I'm going to go ahead and factor out a negative 6, which is going to give me x minus 4. So in my first set of parentheses, I have x minus 6, and in my second set of parentheses, because they match, I have x minus 4. So that's going to be my numerator of my first fraction. So I'm going to go ahead and bring that over, x minus 6 and x minus 4. So now let's go ahead and look at the bottom. I have x squared minus 16. X squared is the perfect square of x times x, and 16 is the perfect square of 4 times 4. So there's a negative sign, a minus sign in the middle, which means that I can factor it out by this rule. And that's going to give me x minus 4, x plus 4. Because that's the rule when it comes to factoring perfect squares. So I'm going to go ahead and put that in the denominator. And then we're going to go ahead and look at our second fraction. So in this second fraction here, my numerator, 2x minus 8, there is a GCF between 2 and 8. So I'm going to go ahead and look at my factor sheet if I'm not sure what it is, 2x minus 8, and I'm going to see that the factors, the GCF of 2x and 8 is going to be 2. So 2 divided by 2 leaves me with 1, so I just have my x left, and then negative 8 divided by 4, divided by 2 leaves me with negative 4. So 2x minus 4 is going to be my numerator, and then here I'm going to do the exact same thing with 6x minus 36. My GCF is 6. I'm going to factor out that 6, and it's going to leave me with x minus 6. So now I'm ready to go ahead and look at my excluded values. I have x minus 4 cannot equal 0 because I'm looking again at everything in my denominator, which means that when I add 4 on both sides, x may not equal 4. X plus 4 may not equal 0, which means when I subtract 4 on both sides, x may not equal negative 4. And then x minus 6 may not equal 0, so when I add 6 on both sides, x may not equal 6. So my excluded values are going to be negative 4, 4, and 6. So now I'm ready to look back at my fraction and see what I can cancel as I multiply. And I see here that I have, again, I can cancel above and below in a fraction, and I can cancel across. So I see here that I have an x minus 4 here and an x minus 4 here. I'm going to go ahead and cancel those. Now I can't cancel this one as well. I can't cancel in threes. I can only cancel in pairs, so just keep that in mind. And then here I have an x minus 6. I can cancel that with this x minus 6. So what I have left is, on top, 2 and x minus 4, x plus 4, and 6. So let's look at that. I'm going to rewrite that down here. 2 and x minus 4, and 6 and x plus 4. So now one thing I need to look at is my fraction will still reduce. So I have 2 and 6, and that will still reduce to 1 over 3. And then I'm going to bring over my x minus 4 and my x plus 4. This is not a situation like yesterday where we had opposites and we were able to multiply, because my x's are both positive. They're not opposites in those parentheses, so don't get confused by that. So this is going to be my final answer. I could also leave off this 1 here. I don't have to have that. Make sure that you have all of that down before you move on, and then we're going to look at some examples with dividing.
All right, so we've covered the first objective about multiplying. Now we're going to look at dividing. It says 3 ways to remember how to divide fractions. One is just to multiply by the reciprocal. Another one is a little saying that's dividing fractions as easy as pie. Flip the second fraction in, multiply. And the other one we call drop, change, flip. You're going to drop the first fraction down, change the division sign to multiplication, and flip the second fraction over. Again, all these are basically the same thing, just a little bit of a different way to remember what to do. Alright, so go ahead and write down number 4. We have x squared minus x minus 12 over 6 divided by x plus 3 over 18x minus 12. So the first thing we want to do is we want to change this dividing problem into a multiplying one, and then it's going to look exactly like the other 3 that you've seen. So we're going to do the drop, change, flip. We're going to drop this first fraction down just the way it looks. So I'm going to say x squared, and I'm going to say minus 1x instead of just minus x, minus 12 over 6. We're going to change the dividing to multiplying. And then I'm going to flip the second fraction over. So drop, change, flip. That's just the way I like to remember it. So my 18x minus 12 goes on the top, and my x plus 3 goes on the bottom. Now it looks exactly like what I've been doing, so I'm going to go through and see what all I need to factor. So I'm going to look at this one first. It's a trinomial, so I'm going to come over here and factor that. I'm going to multiply my first and my last, and I get negative 12. Again, list my factors, negative 1 and 12, 1 and negative 12, negative 2 and 6, 2 and negative 6, negative 3 and 4, and 3 and negative 4. And I'm looking for the one that's going to add to a negative 1. So that's a positive 3 and a negative 4. So I'm going to split this up, and I'm going to bring down my 1x squared plus 3x minus 4x minus 12. Then I'm going to factor by grouping, so I'm going to group my first 2, and I'm going to group my last 2. My first one, all I can take out is a 1x, and I'm left with x plus 3, or 1x plus 3. The second one, I can take out a negative 4, and a negative, because that front number right there is negative. And I end up with x, or 1x, plus 3, because negative 12 divided by negative 4 is a positive 3. Have the same thing in my parentheses, which is what I'm supposed to have. So one of these parentheses is going to be x plus 3. The other one is going to be x minus 4, or 1x minus 4. I just left off the 1. So I'm going to go ahead and put that where it needs to go right here. So x minus 4 and x plus 3. Now if I look at the bottom one, all I have is a 6, so I don't have to do anything with that. I can just bring that down. Then I'm going to look over here at my second one, 18x minus 12. It's a binomial, so I know I either have GCF or perfect squares. Well, 18 and 12 are not perfect squares, so I have to look for a GCF. And when I look for a GCF here, find out that my GCF is 6 of 18 and 12. When I say 18 divided by 6, I get 3. Negative 12 divided by 6 is negative 2, so 3x minus 2. So I'm going to put 6, 3x minus 2, right here. And my x plus 3 is a binomial, but I don't have a GCF and it's not perfect square, so I'm just going to bring down my x plus 3 because I can't factor that one. Alright, so again we're going to go through and mark out what we have that's the same. I have an x plus 3 on the top and 1 on the bottom. So I can mark those out. I also have a 6 on the top and a 6 on the bottom that I can mark out. So then we're going to look to say, okay, what do I have left on the top? I have an x minus 4 and a 3x minus 2. And I don't have anything left on the bottom, so I can say over 1. But if the 1's on the bottom, I don't actually need it. So it's just x minus 4 and 3x minus 2. Please make sure you have all of that work down before you move on. Alright, go ahead and write down number 5. We have 3m plus 3 over m plus 2 divided by m plus 1. Now here we're used to seeing a fraction here and a fraction here, and there's no fraction right here on the right hand side, so I'm going to make a fraction because I can put anything I want to over 1. So I'm actually going to make that into a fraction. So if your fraction's not there, just put it over 1. Then I'm going to change my dividing to multiplying by doing the drop change flip. I'm going to drop the 3m plus 3 and the m plus 2 over m plus 2 down. I'm going to change dividing to multiplying. I'm going to flip that second fraction over. So it's going to be 1 over m plus 1. And now it looks exactly like what I've been doing. So I'm going to go ahead and set this up. I'm going to go through each one. My first one here is 3m plus 3. It's a binomial, so I have GCF or perfect squares. 3 is not a perfect square, but 3 and 3 have a 3 in common, so I can take out a 3. And I end up with m plus 1, because 3 divided by 3 is 1. You have an m plus 3 divided by 3 is 1. So I'm going to put that up here, 3 and m plus 1. I still have my m plus 2 on the bottom. It's a binomial, but I don't have a GCF, and 2 is not a perfect square. The 1 right here can't be factored either. And then the m plus 1 can't be factored because m plus 1 doesn't have a GCF, and it's not perfect squares. So that one was decently easy. We only had one thing that we actually had to factor there, and it was just factoring out a GCF. And I should have mentioned this before on the other ones, but we don't do excluded values with dividing. That's why we've not been finding those excluded values here. Dividing is difficult enough to remember the drop change flip without the looking at the excluded values as well. So we will not find excluded values with dividing. Alright, so now I can go ahead and mark stuff out. So I'm going to mark out my m plus 1s. And that's the only thing I can mark out here. And I can't mark out this one because it doesn't have an m plus 1, it's just 1. So on the top I have 3 times 1. On the bottom I have m plus 2, and I'm going to say 3 times 1 is 3. So it's 3 over m plus 2. So there is my final answer. Please make sure you have all of that written down before you move on. Alright, so there's your second objective, to divide rational expressions. So now you should know how to multiply, and then you should know how to divide by turning it into a multiplying rational expressions problem. Okay, and your homework will be a handout, so we'll give that to you tomorrow. This is the end of your video. Thank you for watching.